So let's discuss about the blind search, breadth first search first. We have discussed in the blind searches, there is a breadth first search. What is a breadth first search? One simple strategy is a breadth first search. In this strategy, the root node is expanded first, right? First, we will talk about the root node, which will be expanded in the all possible childs. Then all the nodes generated by the root node are expanded next, right? Whatever the child has been expanded from the root node, that will be further expanded first, and then their successors, and so on. So in general, all the nodes at the depth D in the search tree are expanded first before the node at the depth D. So firstly, we will expand the all nodes here. So here is a first. Let's understand with the help of a graph here, right? Then we will understand this function also later on. So what is the how you will use the loop and the if or the for statements in a Python here? We will discuss that also. But what is a breadth first search that you need to understand first? अब यहाँ पर in this you can see a graph A B C D E D G all these here. So here the initial state or the initial node is A. And what we are saying in the breadth first search, first the root node is extended to its child. So when the A is extended, it will be in the next two, the frontier will be A in the next step 1, and then in the step 2, the frontier will be B and C. A is removed from the fringe and the node is expanded and its children B and C. You can see here, we are talking about the B and C here. You can see here. So B and C is the dark here. So first the root node A is expanded to B and C, and B and C are generated. They are placed at the back of a fringe, and the frontier is now B and C. Now you need to extend the B first and then the C first. So node B is removed from the fringe and is expanded. And after the expanded, what you have D and E, right? D and E are generated and put at the back of a fringe. So in figure 3, you are showing the frontier is the now C, D, E, right? Next, हमें क्या expand करना है? We need to expand the C node. And when the C node will be expanded, what will be the childs of a C are D and G. So now the node C is removed from the fringe and is expanded, and its child D and G added to the back of a fringe. Now you had expanded the B and C completely, which was the child of your root node A, and now you have a frontier D, E, D, G. In the fourth figure, you can see the frontier is a D, E, D, G. Now node D is removed from the fringe and its child C and F are generated. We will extend the D here, and C and F will be generated and added to the back of a fringe. And now the frontier is E, D, G, C, F. Now you need to extend these. Now node E is removed from the fringe, and as it has no children, so it will not be extended further. So what is the traversal here? A, B, right? So now the frontier is E, D, G, C, F, and after removing the E, we are having the frontier D, G, D, G, and C, F here. Now, what is the next? We need to expand D here first. You can see here, first this horizontal will be extended, and then this will be completely extended. So here, after expanding the D, we are getting B, F are open, are put in a open now. Now, what is the frontier here? After expanding a D, B and F. So what is the frontier here? G, C, F, B, F, right? F, B, F. अब G is the next step, and G is a goal state, and G is a goal node. G is selected for the expansion. It is found to be a goal node क्योंकि यहाँ पर G का end हो गया. So the algorithms return from the path ACG by following the parent's pointer of the node corresponding to G, and the algorithm terminate here, right? So here you have find the goal state. यहाँ पर आप goal state find कर चुके हैं. This is a goal here, right? G is a goal, and this is the best optimal solution here. After expanding C also you will get a G. After expanding F also you will get a G, and after expanding F also you will get a G. But what is the path? What path you have is the shortest path here? ACG. So here you find the optimal solution, and in step 8, G is selected for the expansion, and here it is found to be a goal node. So the algorithm returns the path ACG by the following parent pointers of the node corresponding to G, and there the algorithm terminates. So what the breadth first search is one of the simplest search strategy. Of what we are doing in this, how you will define a breadth first search. Basically, you are expanding each and every child first, and then another child. And in between, if you get the goal state, your search algorithm will be terminated. So what's how you will define? It's a complete if there is a solution, BFS guarantees to find it. So well, let's talk about the definition, or we can say that how you will define a breadth first search. Definition में कैसे define करेंगे? It's a fundamental graph traversal algorithm, right? What we are doing here, we are traversing a graph here. So breadth first or the BFS is a fundamental graph traversal algorithm. It begins with a node, then first traverse all its adjacent nodes. Once all the adjacent nodes are visited, then their adjacents are traversed. So this is a definition that you need to say. Now, what you find in this, it's one of the simplest search strategy. It's a complete, if there is a solution, you will definitely find in the breadth first search. If there are multiple solutions, then the minimum solution will also be found. And the algorithm is optimal, admissible if all the operators have the same cost. Otherwise, breadth first search finds a solution with the shortest path length. So optimality is there. Now, what's the time complexity here? We are saying that O B power D. What B is representing? B representing the branching factor. Maximum number of successors of any node. जितने successors होंगे किसी के node के. Then D is defined here as a depth of the shallowest goal node. Maximum length of any path M in a search space. So here we are talking about, as we are talking as we are using a search technique and we are following a graph, we are following some branches and the depth of that particular node. So the time complexity and the space complexity is defined on the base of a branching factor, which is the maximum numbers of a successors of any node it can have, and the depth of a shallowest goal node it can have. So this is your breadth first search. Now, what is the advantages here? BFS will breadth first search will provide a solution if any solution exists. So it defines the completeness. Another advantage, if there are more than one solutions, or simply you say that the optimal solution can also be found in a BFS. If there are more than one solutions for a given problem, then BFS will provide the minimal solution which require the least number of steps. Then the disadvantage, it requires the generation and the storage of a tree whose size is exponential the depth of the shallowest goal node. तो जितना बड़ा उतना आपका expansion होता जाएगा. Then the breadth first search algorithm cannot be efficiently used unless the search space is quite small. Right, so you need to search it. And what is the applications comes under the breadth first search, or that we have discussed in the state space search also. These applications is the GPS navigation system. In the breadth first search is one of the best algorithm used to find the neighboring locations by using the GPS system. So in GPS system, or we can have the short cautions like that, this, in which what algorithm you use in the GPS navigation system. So in the GPS navigation system, the BFS approach can be used and is the one of the best algorithm used to find the neighboring locations here. Then the broadcasting. Networking makes use of what we call as a packets for the communication, and these packets follow a traversal method here to reach various networking nodes. And one of the most commonly used traversal is here BFS method. It is used as an algorithm that is used to communicate between the packets here and the across all the nodes in the network.